Hi guys, how are you? Good evening and welcome to day 4 of Arduino class beginning. Okay, hi, and as I can see, nobody has joined. It's okay. Let's wait for them. Hmm. So, in today's class, basically, we will be learning about what? We will be learning about basically analog signals. Hmm? हुआ है कोई आया नहीं है. So before the class starts, let me clean the board because today we will be learning about analog signals because from past 3 days we were learning about digital signals, right? So today's analog signal. Yeah. So still no one has came. We will wait for more 10 minutes and then we will start. Okay? So okay. Hi guys. Just let me know that if you can hear me properly and if it's everything is clear or not, let me know. Guys, many of you like in yesterday's class indicator thing only like few people have gave me the code proper code with proper demonstration. I expected more, guys. It was difficult to understand. Let me know if it was difficult to understand. I will again I will take that classes and I will make it everything clear. If you still have that doubts, let me know that. First we will start with a new topic. Hello. Niriksha, yeah. Hello, Niriksha. How are you? So, Niriksha, did you understand everything from yesterday's class? Or do I need to repeat it? So, we will wait for more 6 minutes and then we will start the class, okay? Because since the class is supposed to start on exact 7 o'clock. So, the people who are here right now, let me explain what all we are going to learn today in today's class. Basically, we will be learning about digital and like in past three classes we learned about digital signals, right? One or zero. But in today's class we will be starting with the analog signals or the sine waves. You remember in the day two class we learned about how what is analog signals and what is digital signals, right? So today we will play with digital signals and we will make some fun projects. Okay? Yes, sir. Okay. Can you just tell me like where you feeling difficult? Then I can focus on that part more and I can try to improve and try to explain you properly. Can you just tell me like in which area are you feeling difficult? Or many of you like in which areas are you guys feeling difficult? Let me know. Then I will try to elaborate it and try to make it more simpler with some better examples. But in the coding part, okay, no issues. Okay, we will be focusing on coding part properly today, and I will try to try to explain you each and everything slowly, and by which you can grab it quickly in your brain. Okay, fine. So, okay, then before the class starts, let me revise the yesterday's coding and try to make it easier, like to make it understand. Okay, if you remember in yesterday's class, we made this code to simulate. Okay, wait, let me share my screen. Yeah. Okay, if you remember from yesterday's class, we made this thing, right? Indicator thing. The moment we start playing the code, where in whichever direction we play, we turn on the switch, it will just turn on that part, right? Now, if we see the code of this entire section, see, uh, if you see this side, you can see the LED number, red LED is connected to pin number 13, right? Because Arduino has few pins which are meant for digital signals for IO, like on and off things, and there are few pins which are made for analog signals. Okay, now we are playing with digital signals. Okay, so wherever there is nothing is given, just only numbers are given. Default, they are known as digital signals. So here you can see from pin number 0 to pin number 13, they are all the digital signals. But make sure whenever you are making a project, try to avoid pin number 0 and pin number 1, because as you can see here, pin number 0 and pin number 1 is written TX and RX. Now what is TX and RX? TX means transmitting, RX means receiving. So whenever you are trying to upload a code into an Arduino, what happens, these two pins are being used during that case. And if you try to connect something here which will interrupt the code which is going to upload in this chip. What is the chip? This is the chip. Okay, this is a chip. Whenever you are trying to upload the code in this chip, the major issue will be you will be facing issue that you are not able to upload it. Why? Because you are interrupting with digital 0 and digital 1. That's why you always try to avoid it. It's not like you can't use it, you can use it, but yeah, while uploading the code, you make sure that you remove these two pins. Okay, this is the one thing which we learn as this is the one thing of digital part. Okay, now there is a something known as analog pins also, which always starts with A. You can see A0, A1, A2, A3, A4, A5. Getting my point? Now, as per the code, if you see the code in pin number 13, there is a LED, green LED, sorry, red LED, and in pin number 10, there is a green LED. These are the two names, as I told yesterday. Like instead of calling your roll number every time, people will be not knowing your roll number. So, to remember you, they will try to call it by your name, right? They will try to call by your name. Getting my point? Okay, wait. I can't see your chat. Yeah. Okay. Now, as I told just now, key these are the digital pins, right? Digital pins. So you can see the in pin number 13 and pin number 10, we have connected LED. So I have taken instead of calling the roll number every time, because I will be not able to remember numbers, because we human beings are better in remembering names better than numbers. You can remember your friend's name, friends parents name, everything. You can remember the name quickly, but did you ever try to remember their phone number? It's a really difficult job, right? Because you need to keep on by hearting multiple times until unless you are a genius, right? So same thing, human. It's a basic human tendency that we were always flexible with remembering names. So we always give a name instead of giving a number to it. So I can call pin number 13 everywhere, but I can forget. No, what was this pin was? So again, I will go and check in the circuit. Like, okay, this pin number 13 was for LED. In real life scenario, when you are playing with multiple pins, you will forget like which pin is for which part. So it's always better to use variables. So this is the part where we learn. And why we use int, like if you have the basic knowledge of C++ languaging, like whenever you set a variable, you should always be like data type, variable, then you should go with like value, data type, variable name, and then value. What is the value? Okay, in this way we always go. Then here also we have two in sensors, like two sensors means two buttons, right? So I have kept it L in and R in, and since they are also integer type, so I told that in pin number 12, pin number 11, like that. Okay, now void setup. Void setup is a part where like we are setting up everything. In a general English term, what do we understand by void setup? Void setup means anything you are setting up before you start doing anything, right? Example, when you are now in today's class, when you are setting for this class, you will take a book, you will take a pen, you will make a laptop ready, everything. So you're setting up the things, right? So this is how the Arduino also setups before it starts anything. So I told that sorry, pin number 13. Now what is pin number 13? Red LED, right? So red LED. What is a red LED? It's an output and input device. It's an output device. So I told pin mode. Mode means you got to know what is your mode, input or output mode. Okay, so I wrote pin mode. Pin means what? Of course, Arduino pins. So you are telling mode of that pin should be input or output. The Arduino is expecting to give something or take something, right? So you are mentioning it here, like pin mode. Then what is a variable, like whatever the pin is, and what is it meant for, input or output. Okay, this is a void setup part. Then if you go into void loop part, again in void loop part you can see digital read and digital write. We learn digital signals 1 or 0, right? So to read something I will be using digital read, like it's a layman English term, right? Digital read, and is equal to 1. Now why is equal to 1? Because I am trying to see that the input of L in is a pin number what, pin number 12. So I am seeing pin number 12, whenever I am reading it, it's giving me 1 or 0. If it is giving 1, turn on the red LED and keep on blinking and using digital write. And if I use or else, keep on blinking the pin number what? Green LED. What is green LED? 10, pin number 10. To keep on blinking the pin number 10. So this is how we did the basic coding. Okay. Niriksha, did you understood the entire coding part now? Like, is it clear now? Let me know. And any other people, like any of you have any other doubt, let me know. Then we'll start with a new topic. Okay, everything is clear. Like, did you understand the properly, like the entire coding part? Yes. Okay. Great. Okay, so in today's topic, we will be learning something new because from past 2 days we were learning about analog and digital signal. Digital signals, right? From past 2 days. And if you remember, at the beginning of the classes, we learned about difference between analog and digital signal, and we learned about sensors and actuators, right? We learned, now we practically use a basic actuator and sensor, and we made some like yesterday we made some projects. Right now we will touch into the another part, another side, which is the analog signals. Okay, now let me show you in the screen, screen properly. If you like, it's like a quick recap. Let me show you how the things goes. Okay, now in yesterday's class we learned about, not yesterday, from past two classes we are learning about digital read and digital write. Right now, if you remember what is digital read and digital write, reading and writing only two values, because computer can understand only two values, which is 1 or 0. It can't understand anything more than that. So if you see this kind of table where it is time, okay, it is time. Is it visible? Yeah. And if you go with this one, this is voltage. Okay. Now, whenever you try to run anything in this, like whenever you're writing any digital signals, the digital signals, whenever you plot a graph, it will be looking like square waves. Right? It is looking like square waves. What is the highest peak? It can be your 5 volts. Since Arduino is running on 5 volts, right? It is running, it's a 5 volt. The top part, peak level. This one, right? Now, what will be the bottom part? Bottom part will be your 0 volt. It will be of 0 volt. Okay, 5 volt or 0 volt. It can't go anything beyond that. So this is what in digital signal we learned. So whenever you are reading a digital signal also, Arduino knows it is going to read only two things, 1 or 0. It can't read anything else, right? But if you go with the analog signals, as I told, entire environment is filled with analog signals. In real life also, everything is analog. The thing is, we need an encoder to convert it. Now, if I show you the Arduino, I will show you the Arduino diagram here now. If you see this Arduino, here in the bottom, bottom left corner, you can see Arduino pin number A0 to A5. It is given, right? Now A0 to A5 is basically your analog pins. Now it has something known as ADC, analog to digital converter. The chip inbuilt has a ADC encoder. Again, if I repeat, ADC means analog to digital converter. A for analog, D for digital, and C for converter. Okay, so using this, we will be trying to take the real analog values which is present in the environment. Okay, now you will be saying like, why analog values? Now, if I take an example of, you have made a pot. Okay, so if you have made a pot, okay, let me again open the screen again. If you have made a pot, right, what will you have made a pot which will be having a plant, and you need to water it, but we don't know how much to water it. Should I put more water, should I put less water? Now if you are trying to keep a digital signal, so what it will say, oh, you have put water, don't put water now. It will be like only 1 or 0, because it doesn't know the difference between the amount of water should I put. Because if you have a basic knowledge of this thing, chemistry. Okay, now example, if I take an example of soil sensor. Okay, soil sensor will have two lids. The soil sensor will be having two lids. Now it will be in a jar. Okay, like it can jar, it can pot, anything. Right. Now, in like you have learned about, right, in chemistry in your class 10th, 11th, 12th, if the water is distilled, it is a non-conductive water, right? The more you put salt, the more impurities are there in that water, the water starts conducting, and that's how you have made a project where a circuit it completes in a distilled water circuit will not be complete because there is nothing to there is no electron to move from one part to another part, right? But when the moment you start putting salt in it, what happens? The light glows up. Why? Because now there is an impurity in the water. The same way, when the soil is dry, it will be like it is non-conductive because soil is not a conductor. You are putting water to make it as a conductor. Now, if in the same place, if there was a digital signal, if you have taken a sensor which can give only one or zero, the moment I put little bit of water here, little bit of water which can wet these two terminals, it will be like okay, you have given a water. But remember one thing: the water should go till bottom, right? Then only the plant can grow properly. So how much water I should put? So in this kind of scenarios, we use analog signal sensors, okay, which can give us the like how much water to put because the more water we will keep on putting, the more impurities will increase, by which the conductivity of the soil will also increase, by which we can able to identify how much water we have given and how much to put. Right. This is one of the basic examples of soil why to use analog signals. Now, if you see, there is something like sweat sensors. How the sweat sensor works? Our skin is not conductive. No, it's conductive, but if you just keep two wires, it will not glow in light because it has a higher resistivity. It has too much of resistivity. Now, when there is a two terminal touching our body, okay, when the two terminals touch our body, what happens? Now, since there is a high resistivity, it will be having a very minute signals which is negligible, but the moment we start sweating, so what does a sweat has? Salt is a good conductor. So what will happen? The slowly the more sweat comes in our hand, the more the like conductivity increases, means resistivity starts dropping, right? By which we will get to know, okay, this person is sweating a lot, right? These are the few real life applications where can you use analog signals. Now, again, example, one more example I can give. Sunlight intensity. Now, you want to make a machine whenever the sunlight rises, like whenever you see the sunlight, automatically your home light should turn off. Or else, example, today little bit it's cloudy and the room is dark. What you want? If the room is dark after this level, there will be you can mark a level. If it is darker than this level, do one thing, just turn on the lights. Okay, so in this way, you don't need to go and manually turn on and off the lights. Now this temperature sensor, then all those environmental sensor which take environmental data, they are mostly will be analog signals, and we will be having a small onboard ICs to make convert it into computer readable form. Okay. So I guess you guys got to know where are the applications we can use analog signals. Now, if you forgot like how the analog signal looks like, so analog signals will be looking something like this. So you have voltage, right? You have voltage, then you have time. You have time, you have voltage. Now, as I told, analog signals are everywhere. How does the analog signal looks like? Whatever I am doing, is it visible to you guys? It is T. If you can't read, I can make it bigger. It's T. It's V. What is V? V is voltage. T is time. So this is an analog signal. Now, in digital signal, we were knowing that we have a range of multiple signals, but it can read only one or zero. But in analog, you can see here it can be 0 degree. As here it can be zero voltage. Here it can be like something around 1.2 voltage. Here it will be like 3.3 voltage, and the peak level will be 5 voltage. Right? Based on this voltage change, which is happening and which is generating this kind of wavy format is an like basically analog signal. Now, where can you see this kind of analog signal? So, analog watch. As I told in the day one, whenever your watch battery starts getting dead, like it's about to get over, you see that your analog clock will slow down. Why? Because it's running on analog signal. This frequency is getting slower, by because of which the clock starts rotating slowly. But in the same case, if you go with a digital watch, if the digital watch battery goes down, nothing impacts. But the moment it's below some certain threshold, then it turns off. But it didn't. It will never change the timing, right? You might have noticed it. It will not change the time, but it will just turn off. That's it. This, but in the analog signal, you will not see like that. That's you will see that hour hand and second hand and like minute hand, it will start going slowly. The way the battery keeps degrading, right? You got to know now. Did you got to know where can we use this kind of analog signals and how does the analog signal looks? Let me know if you have any doubt. I will explain it again, and then we'll start with this, some small fun examples, and then we'll start the coding part. Okay? Let me know, guys. Did you understood everything or not? So, example like now in today's class we will be making one small like we will take 5 LEDs, and what we will do based on the based on the analog signals changing, we will be trying to increase or decrease the pulse of an LED, brightness of an LED. Okay, you will try to like control the brightness of an LED, or else you will be trying to like change the meter kind of things. We will be doing this kind of fun projects. Okay. Okay. Okay, Monica, see, do you have any did you strike anywhere? Let me know. I can fix it. Like if you didn't understand any part. Oh, you have deleted it? Okay, no issues. Now, we'll be starting with the coding part. Now, if you remember yesterday's code, if you can look back to your notes, whatever you have written, if you see, there was two functions we have learned, digital write and digital read. So, can you just give me just Tukka you can say. Right, can you just say me? If I want to read or write anything in analog signal, what will be the function name? Can you tell me? What should be the function name? Like if I want to write or read something, what should be the function name? Can you tell me? For digital cases, whenever I want to turn on and off any light, I'm writing something in digital, I used to use digital write, then pin number, then on or off, right? If in the same case, if I want to do something in, if I want to read, like the switch is on or off, then what I should do? If I want to read, digital read, pin number, and these things. Okay. So in analog, what we will do? Yeah. Yes. Nick. Sorry. Yeah. Correct. Analog. Yeah. Correct. Who is this? Niksha. Okay. Niksha. Okay. Okay. I'm pronouncing it wrong. Okay. Sorry. Okay. Yeah, you're correct. It's analog read and analog write. Right. Now we'll be starting with the real coding part. Okay. Let us move on to the coding part. Open your Tinkercad. Okay. Now again you can take your Arduino. Okay. I will delete all these things. Okay. You have your Arduino here now. Now, as I told, what I want, keep based on the potentiometer, like based, I will be keep on reducing or increasing the brightness of an LED. Okay, I want to increase or I want to reduce the brightness of an LED. So for this kind of applications, we will be using potentiometer. Now, if you don't have a knowledge of what is potentiometer, let me explain you with the example. Okay. Now, this is a potentiometer. This is how it looks like. If you can see here, I'll draw it here right now. 1 second. Potentiometer is an electrical device which basically does to control the resistivity. Example, okay, let me increase the screen size. Example, in yesterday's class and day before yesterday's class, we learned about registers, right? Registers, we will be using a register which will be having some fixed resistivity. Okay, this is a register symbol, right? And it can be any ohm. It can be 1 kilo ohm, it can 220 kilo ohms, anything. But then the resistivity will never change. It will be always remaining same. But potentiometer is a device where you can change the resistivity. Okay, the symbol of potentiometer will be something like this. Getting my point? So what you are doing, this arrow is going back and forth. It will be going back and forth. So by which you what are you doing? The more you rotate clockwise or anti-clockwise, you are basically changing the resistivity of that conductor. Like this resistor will be having a max value. Example, if you go and market and buy in a register, it will be having a max value of 10 kilo ohms. Okay, I will show you. I have one resistor in with me right now. Let me show you. Um, yeah. How does a like a potentiometer looks like in a real life scenario? This is the potentiometer. Can you see it? This is a potentiometer which is basically used to change the resistivity. Example, I will be rotating this knob. By rotating this knob, I will be changing the resistivity. There are three terminals here, right? Now this terminal 1 and terminal 3 will be having a fixed value. The center terminal will be keep on changing based on how much I am rotating it. Okay. Now, where do you see this kind of like this kind of regulators? Can you recall? You use it every day in day-to-day life. Just try to recall it. Where do you see this kind of potentiometers? Also, where do you use every day in day-to-day life? Can you just give me an idea like where do you see this kind of things? Till then, I will draw the signal, like draw the diagram of this potentiometer. So can you just tell me like where do you see this kind of things? Yeah, fan. Pratik. Yeah, correct. Fan. One example is fan. Another place, any other examples can come up with? Switchboards. No, switchboard like both are same only. Okay. Regulators, fan, whenever you rotate it or clockwise or anti-clockwise, the speed of the fan changes. Why the voltage is getting deferred here? Now, if you go with your example, your volume control, like if you have a box like home theaters in your house, there will be a small potential which you rotate it to make increase the sound or decrease the sound, right? These are the few places where do you use this kind of potentiometers every day in day-to-day life. Yeah, audio control, correct. Okay. Now, since now you got to know where do we use this kind of potentiometers. Now we will be having some fun and we will be trying to change the brightness of an LED by rotating this potentiometer. Okay. So before I start writing the code, yes, in my day two class, I have explained something around PWM signals. You remember? Now what happens? As basically a computer can generate digital signals, right? But it can't generate analog signals. For that, we will be having complete different circuit boards to convert a digital signal into analog signal. But a computer, like a computer, can mimic a digital signal. How does it mimic? Now, I will give you one task. Now, see any side of your like wherever the light source is coming in your house, see towards that. Now, the moment you are seeing towards that, example, if you see my eyes, I am seeing it straight. So I am see I can get as much as light I can. But if you start blinking it rapidly. Okay, what is happening when you start blinking rapidly? that level of things you are seeing, it gets reduced. The brightness of the house gets reduced, right? Basically, what happens if you are from biologic background, you know, right? Whenever we see any like suddenly we see a very like high amount of light, our cornea, guess what? Our cornea shrinks, right? By which you are reducing the amount of light entering inside your eyes, right? This is an analog value. But in a real life scenario, what will happen? A computer can't generate an analog signal, but it can mimic as an analog signal by blinking it quickly. Now, if you see my hand, assume it's an LED. Now it's blinking and closing, right? But if I increase the speed very rapidly, can you see? Like though even I am doing it very fast, but you can see that my hands are still in the top only, right? You don't see anything particular. You see the all the ranges, right? What is happening? Basically, you make it so fast that your normal human eyes can't differentiate it, and it looks like you are increasing or decreasing the brightness of an LED. Okay, this is known as duty cycle. Okay, I will explain it again, like in using diagram. What happens now, since a electronic device can't generate like analog signal directly, it will mimic it. Now, if you see the diagram, again we have a voltage diagram with time, right? Voltage with time. Now, the more I increase or decrease the frequency of the on and off thing, and again if I try to reduce it, right? Is it visible? Okay. Okay, but yeah, though it's not visible, you can see that this part is like it's taking long time. There's a long time of on, off, again on. But if you see this part, it's like on, off, on, off, on, off, on, off, it's in a fraction of second. Now you can see one thing, you can see this area is darker in color, right? And this area is lighter in color. So assume darker colors always fades out. So the longer this exposures of the light are, the more the light will be brighter on your face. The more it is clumsy. What will happen? The LED brightness will reduce. The light brightness will reduce. Okay, by which what is happening? Though even it is not an analog signal, like what we did, analog signal means it should go up or down, right? In this like wave format. Now the wave should be in the downside to make the voltage low. But since Arduino can't do that, so what it is doing, it is trying to mimic it. By which what is happening? Since it is doing it so fastly, it automatically becomes down. So human eyes feels like the LED is very low in light. But if what you will do, you can take your camera, and the moment you take like try to see that LED blinking from your camera, you can see a small like fraction of blinking which a camera can see, because camera shutter speed and the LED blinking will be almost same. Okay, so did you understood the PWM signal which we learned? Basically, in again in one shot, if I try to explain you, PWM signals are the signals which tries to mimic an analog signal using the amount of frequency to turning on and off something. Got it? Did you understand this PWM part? Let me know if you have understood the PWM part. Then we'll go with the coding part. Okay. Okay. Any doubts? Okay. So I assume there's no doubts, and we'll move on to the coding part. Okay. Yeah. So here we have a potentiometer. Okay. Now we will be giving a signal to it, right? Now we'll make it 10 kilo ohms because I love 10 kilo ohms. Now one of the terminal I will connect it to 5 volts. Okay. Based on the change of resistivity in this 5 volts, I will be calculating. And under my other wire, what I will do, I will try to connect it with analog signals. Okay. Now this will change the resistivity. Okay. What it is doing, it will change the resistivity of this pin. Getting my point? Now, what we will do, we will start with the coding part. Now, just today, I just want to see what is the output I am getting. So, I will go to the code part, and if you are using any digital signals, just we directly write the numbers, right? Pin number 13, pin number 12, 10, 11, 9, 8, 7, 6, 5, 4, 3, 2, 1, anything. But if you are going to try anything with analog signal, we always write A at the beginning. Okay. So, I will write int, then int I will be taking potentiometer. I will take the pot is equal to A0. A0 means what? Analog pin number 0. Okay. A0. Now what I will do? I will just set up. Void setup. You can see the screen, right? Void setup, and now pot is an input or output device. It's an input device, right? So I will write pin mode. Yeah. Okay, I will share all the notes of this coding part by today night. Okay. Till now, whatever code we have done till now today, I will share all that. I will share all the notes. Don't worry. Okay. Just remind me once again before ending this class. Okay, Monica? Great. Now, pin mode. Pin mode again we will let pot. Pot is an input or output device. It's an input device. So I will type input. Okay, done. Now void mode. I will say void loop. Void loop means what? It will keep on repeating the same task which we learned in past two classes. Now we will be reading it. Now to read, I need to store it somewhere. No, I can't just read and throw it, right? I need to read and store it. So I like int. I will take int uh, results or r. Results is equal to what? Digital read, right? DIGITL, digital read. R is capital. R is read. Digital read. Now digital read is what? Like which pin I am reading? Pot. Pot I am reading, right? Now I have read everything. Now how can I see? Because if you are writing a normal C language, you can use printf, all those things. But it's an Arduino, right? How can we see it? There is something known as UART communication. Now, if you remember at the beginning of the class, when I started this class, I told you one thing that never mess with TX and RX pin because this has been used to communicate between the Arduino and the computer or while programming it, right? Now we will be using these two pins to communicate and we'll try to get all the data from the Arduino. Getting my point? So how to get data from that pin? So there's something called as serial communication. Okay, you will be hearing this commonly when you are dealing with a real life physical Arduino. Okay, something called as serial communication. So I'll just type serial S capital ACRL serial dot begin. Now what serial dot begin means? Beginning. You are starting something, right? Beginning. Now, Arduino communicates in multiple languages. Okay, it talks in multiple languages like multiple frequency, multiple all those things. Now, if I also want to listen in this similar format also, there will be a format. Basically, standard is 9600. 9600. This is known as baud rate. Okay, baud rate means in which speed the Arduino is communicating with the Arduino as a computer. In which speed the like Arduino is communicating with the computer. So that we have taken a 9600. There are multiple. If you see the tinker at bottom, there is a serial monitor. If you click on it, and you will be have okay in simulator we don't have an option, but in when you are using a real Arduino, you will be having an option of multiple ports, which port like which baud rate you want to select and communicate with. every chip will be having a different speed to communicate, right? So, and 9600 is a popular one which is generally we use communicate. Okay. Now serial begin. What this function says? Serial dot begin. It means that you are turning on an you're turning on the communication part between Arduino and computer in this baud rate. Now what computer will do? Computer will read or write in this baud rate and it will be trying to listen Arduino whatever Arduino is saying. Okay. Now what I want to do? I just now told, right? I want to read the potential value, potentiometer value, right? So I'll just serial again ACRL serial dot println print ln. Now why println? Now print means printing something. Ln means new line. It is going to a new line. After it prints it, it will go to a new line. If you know a basis of any programming language, you will be having print, println, printf, all those things, right? So println means it will go to the new line. So what I want to print? I want to print R. Okay. Now let's start the code and check how does it response. Okay. Okay. Sorry, I forgot this thing. Okay. Now again, let's start the code. Now you can see here it is showing 1. I'm increasing, still it is 1. I'm still increasing, still it is 1. Now you will be saying, okay, what is going wrong here? Did you remember anything? We have missed something here. Whatever high voltage is coming, it's directly going to where? A0. Right. Now let's try to change this pin. Okay, I might be like, okay, I might be wrong. So what can I do? Just try to change this pin and let's see how does it respond. Still you are seeing 1. Though when you are rotating everything. Did you identify where did I did it wrong? Something is missing here. To complete a circuit. Let me know guys what I am missing here. A ground pin. Which will help me to complete a circuit. Okay. Got it? Let me know. Because to complete a circuit, actually you should have a negative point, right? Now again we'll start the code and we'll see. I start the code. 0. Okay. Strange. It is still showing it 1. Did you got where did I read the error? Though when I have connected 3 wires, all these things, still it is showing 1 or 0 only to me. Can anybody identify where did I did it wrong? Because who replies in 1 and 0 format? 1 or 0. It is just replying me in 1 or 0 format. Where did I did it wrong? Can you just show me? I am trying to give you a hint also. Tell me where did I did wrong? Basically, I have used a digital write. This is a digital read. Okay, what does digital read means? Digital read can only read 1 or 0. Right. This is the biggest mistake which I have done here. 5 volts. No, not 5 volts. It is function. If you see the code properly, it's I have written here digital read. What I told at the beginning of the class. If you want to read anything of analog signal, which function we should use? Analog read, right? Do you remember? So to fix this, we need to write analog read here. Now what analog read will give? It will give me in analog signals. Okay. Now if I try to run it again, yeah. Okay. Now if I try to increase, you can see in the bottom part it is increasing. The way I keep on rotating the potentiometer, 0, 184 to in this way, and max it is going till 1203, 1023. It's going max till this much. Got my point? Now, did you got to know the analog part? How to read analog signals? And did you got to know where did I did the mistake? Pay attention, guys. In the class, you should be knowing that where I am doing wrong. Yeah, only Jeevit wrote the correct answer. Analog read. Yeah. Now, as I told, I want to increase and decrease the brightness of an LED. Now, if you remember at the beginning of the class, I showed you one diagram, right? Analog can go from 0, like Arduino can read from 0 to 255, right? It can't go beyond that. But if you see this serial monitor, it is giving me 1023, which is beyond this limit, right? So how can I reduce it to 255? There is something known as mapping function. Okay, there is something known mapping function where you give the highest and lowest value, and then you try to rescale it to smallest and new lowest and maximum value. Like you might have learned in a mean median mode in a mathematics last subject, where you scale down any kind of form like numbers, where you will be having a max value, minimum value, and you will be converting that max value and minimum value into a new minimum and max value. So whatever comes in that range, it will be fitted automatically in this the new range. Okay, getting my point. So there in Arduino there is something known as mapping function. So I will map it. Okay, what I will do? I will map it. So I will take int again, int m. I will take m as a variable. And I will map it. Map for mapping. I will be using map function map map. Then in map function, what I will do? What variable I am taking? What variable I am taking, whose value I am reading from that time? R value, right? I am printing the R value. So I'll type R. Then what is the minimum range it can go? When we played this potentiometer, you saw the minimum was 0. So I'll type 0. What was the maximum value? Maximum value was what? 1023. Right. This was the maximum value. Now, what should be my new scale? Just now I told in PWM, like Arduino can read between 0 to 255, or it can make a signal between 0 to 255. So I'll make it 0 is a minimum. Maximum is 255. Okay. Now I will try to change here from R to M. Now if I again start playing it, you can see it's showing 255 default, and the way I keep on reducing it, 0. See, the max is going to 55 now. Remember earlier it was going till 1023. Now it is going till maximum 255. This is how we reduce the range of Arduino to read this much big into smaller value, which will be easier for you to write. Because when you play with analog signals, this kind of big analog signals, what happens? Ki you commonly get confused, like which signal should I tackle with? So if you reduce that range in normal readable form, which Arduino can read it quickly and easily, then it will be easier for you also and for Arduino also. Okay. Now we made a potentiometer and we got the values. Right. We got all the values in lowest and highest value. Now we need to change the brightness of that LED. Okay. We need to change the brightness of that LED. What we should do? We'll connect a signal. We will connect a LED with a PW and we'll be giving it PWM signal. Now, if you remember, one thing, PWM signals can be generated using digital pins, but Arduino has little bit of drawbacks. So Arduino can't generate that kind of this kind of signals which I have drawn in backside in my board. Same signal is can't generated by all the pins. Only few of the pins can generate this kind of signals. So if you see this Arduino closely, you will be seeing in front of 11, 10, 9, 6, 5 and 3, you will see a wavy format. What does that wavy format means? If you see in this bracket, it is written PWM, pulse with modulation. You remember in the day 1 of the class and day 2 of the class, we learned about this pulse with modulation, where you are trying to mimic the analog signal by changing the frequency of on and off, right? So we need to choose any one of these pins to mimic the same analog values. Now what will I do? I will take an LED now. Okay. Where is an LED? Yeah. I have taken LED now. Now I will connect the cathode. I will connect cathode to cathode. I mean cathode to ground, and resistor we need to protect the circuit, or else it will burn. Connect it to positive, and I will connect another end to pin number 11. Now, why pin number 11? You can see the pin number 11 has a wave format, which means it supports PWM signal. Okay, now I will start writing the code again. Again, I need to write the LED is connected into which pin? LED is connected to pin number 11. Right. LED is an input or output device. It's an output device. So pin mode, pin M capital, MOD, pin mode. LED is an output device. OUT, output device. Right. Now, we learn about the analog read. Now, if I try to mimic that PWM signal, what I am trying to mimic? Analog signals only I am trying to mimic, right? So, what function should I use to mimic that analog signals? Now, we learned if you want to write something in digital, you will be doing digital write. If you want to read something, you will do digital read. In analog, we have done analog read, which will read the value of the potentiometer, right? Now, how will I write it? What is the function name I should use to write signals into this LED? Can you just tell me? I'm waiting for your comment, guys. Basically, it will be your analog read, analog write, right? Now, since we have changed the range now, as I told, PWM pins can generate only from 0 to 255. Yeah, analog write. Anjali, correct. You're correct. Analog write. Now, what I will do, I will try to change the pattern of this, right? Now, I will write analog and analog write. Yeah. Analog write. Manoj, not analog read. It's analog write because you are writing the thing, right? Getting my point? You have read already. What is the potentiometer value you have read and you have stored into R value. Then you are trying to map it. As we saw that potentiometer was giving from 0 to 1023. You have changed it to 0 to 255, which Arduino can understand properly and generate. So now after reading it, we will write it. Analog write. Now which pin we are writing? LED, right? LED. And what should be the, like, in how much pulse should I generate? You know where is the pulse value is kept? M, right? I'll just write M, right? I'll just write M here. Okay. Now if I try to run this code now again, if I try to run this code, oh, okay, serial M, again I forgot. I keep forgetting this part. Okay, there's some issue, I guess. I can't type. Ah, mm, okay. It my this thing got stuck in initialization. I reload the page once again. There's a small glitch in my web page. God. Okay, I need to redo everything again. Now, it's better, we can again recall. Now, potentiometer positive will go into 5 volts, right? Then terminal 2 will go into negative ground. Now, the signal pin will go into analog 0 to read in analog values, right? I'll do it quickly. Then I will be taking an LED and we will be seeing which pin supports PWM signals. Pin number 11 I can see which can support pin number like PWM. I'll just connect it. I'll just make it to 55. Sorry, not 220 ohms. And I'll just connect it to yeah. Then connect the cathode to cathode. Done. Now if I go with the coding part, oh my god. Int LED potentiometer is connected in analog 0. So how will you write analog 0? A0. Remember A0. Then int LED. LED is connected in pin number 11. So I will write 11. Then void setup. In void setup I am taking two values, input and output. So I will just write pin mode pot is output. So pot is input, then pin mode LED is output. Now we'll start a loop, while loop. As we saw, now we need to take the raw data. What is the raw data? Where will you take? I'll take a variable R, and I'll keep everything in it. So I like analog read, analog read will be taking a value of pot, right? Now I need to map it because a computer can't understand that much big values. So I will reduce it. So int map using mapping function. Now watch what variable I am trying to map. R value. What is the minimum? 0. What is the maximum? 1023. What is the minimum you want? 0. What is the maximum you want? 255. And then I will try to run it. Like I will try to change the brightness. So I'll write analog right in analog right W capital, also known as camel casing, analog right. Then I am writing to which pin? LED pin. LED, comma. What value I want to write? Like what should be the signal frequency? Map, which is ranging between 0 to 255. Then I will start running this code. Okay, till here we did it previously. Now we will start this code again and we'll check. Now it has started. Now if you see, this LED is glowing little bit dim. It got completely closed. Okay, what I will try, I will just try to reduce this resistivity by which you can see more properly. Okay. Now if I try to change this potentiometer, you can see how brighter it is going. Like the more I keep rotating it, see, it's reducing now. Increasing, reducing. Got this point? Till here, did you got everything? And since you have the m value now, the m value you have right now, right? So you can do a if condition and you can play around with. Like example, I can show you one example. Just take this LED, make a copy, multiple copy of it. Now what you do, just connect all the cathode to cathode. Got till now you have got everything. Let me know if you have understood everything or not. Then based on that, I will go into next topic. Like not next topic, I will try to make it more advanced. We'll have fun. Now, as we know that PWM signals can generate by pin number 11, 10, and 9. I'll just connect pin number 10, 11, and 9. Okay, you can see here. Now, what I will do, I will just change the code since I know what is high volt and what is the low and what is the higher part. Right now, if you see this code, if I am keeping it fully high, it is turning off. Right, if I am keeping it fully low, it's turning on. Resistivity is changing, right? So what I can do, I can just make it like a green LED. Okay, wait. I can make it as a green LED. I can make this as a red LED. No, it's already red. I will make it yellow LED. Okay. In this way, you have made three red, yellow, green. Now, in the coding part, what will I do? I'll just try to put some if condition now. Example, I'll say if. Okay, wait. I need to add two more LEDs, right? So I'll just add in LED 2. It was LED 1, right? LED 2. Now here we will be having pin number 10, then int LED 3, which is be pin number 9. Okay, now all these pins are like output device. I'll just copy paste this one only. 1, 2, and 3. Okay, wait, something is going wrong here. Okay, we don't expect like this. Okay, OUT, PUT output. OUT, PUT output. Okay, now since all the three pins are output and since we know the range, what will be the range? So we can do one thing. If M is going below then, if M is going below then, um, 80. If M is going below than 80, then what you do? Digital write, right? Because now I will be writing the LED on and off. So digital write, yeah, digital write. What will I do? Digital write. I will be like, okay, I will turn on the LED one. LED one on. Okay, and rest all LEDs will be off. Okay, so I will just copy paste it and I will just turn all everything off. Okay, LED 2, 1, 3, comma. Okay, wait, no. Okay, now I will do one thing. Now if else if now if we run now another is else if else if like if not that condition then read this condition. If M is greater than or is equal to 80. And how to use and here? In Python we write a and d and right, but in C language we write double and like double ampersand sign and m is smaller than or equal to smaller than or equal to 200. What should you do? You should turn on the LED 2. So what we'll do? We'll just take this code. Okay, we'll turn on the LED 2. Or else what we will do be doing? Turn on the LED number 3. Getting my point? Got it? Now we'll try to run this code and we'll see how does it react. Okay, there's an error here. Again, we forgot. Again, it got stuck. Hmm. Again, it got stuck. I don't know what is happening today to this browser. Reload and expect nothing should go. Everything is here only. Great. Now we'll go to the coding part and we'll try to implement this and then we'll start the code. Now, the moment I start the code, error here. Oh shit. Yeah. Now you can see the pin number red is glowing. Now I'll try to increase the. See, now yellow is going. Now green is glowing. You can see I can change the LED which light should turn on by changing this thing. So what can you do? You can make a array. You can make you can make some patterns where you can change the pattern of that LED based on your potentiometer value. Okay. Did you understand this part? See, you can see this part closely. Whenever I'm rotating this potentiometer, it's switching that green, yellow, red, green, yellow, red, switching between that. Is it great? Right? It's great, right? Did you understood till here? Did you understand the entire coding part? Let me know. Then I will revise it completely once again, and I will give you some homework today to do. Let me know, guys. Did you understood everything or not? So I can make one more pattern here. Like I can just make it like whenever this is on, I will be just like make this to on. Whilst when I am 0, I will make everyone on. Okay, now if I try to run the code and if I show you, all the three are glowing. But with the moment I keep reducing the pot, you can see one by one LEDs are turning off. But the green LED is not turning off because we have not given a code for green LED. So in this way, you are turning on and off LEDs now, right? It's fun, right? Yeah, did you understand each and every part of this today's code? And where can we use this kind of analog signals? And in tomorrow's class, we will be having more fun activities using these analog signals. Okay? 2 days we have learned everything about digital signals. Now again, we'll take 2 days to learn everything in analog signals. So I hope today you have understood this part. Let me know if you have understood, and let me give an homework for today's class. So your today's homework will be okay. Let me type change pattern of an LED based on. Okay, your today's homework is like you need to change the potentiometer. Whatever is knob is there, try to rotate it and change the pattern. Like example, if the potentiometer value is between this or this, then run LED from left to right pattern. If it is in another range, then try to make it in right to left pattern, or else make some other patterns. Keep changing the pattern based on the potentiometer values. Okay, I hope you can do this kind of project. I hope you can do, and please do share me the video of this code, because digital signals I can just see the picture and I can able to identify. I can identify the things you have done correct or not. But this time you show me the video also, like how are you changing it, and let me know. And again, tell your roll number and name by which I can inform to the Ramesh sir. Okay, sir. In this code you have use digital write instead of digital analog write. Why? Because see, here I am not trying to change the value, right? Here I am not trying to change the value of the LED. I am just trying to on and off based on the potentiometer, like how much I am rotating the potentiometer, whatever the range is coming. Based on that I am trying to turning on and off. If I want to increase or decrease the brightness, you remember what the code which I wrote, like, you have mapped it. Now I will just write digital write. It was right. Now I will use digital read. Now I read analog read now. Analog write. Okay. Now I have used analog write here. Okay. By this analog write, what I am doing, I will be trying to change the value. Now if I try to run this code, what will happen? This LED is glowing, but why these two are not glowing? Because I have given already the value, but I want potentiometer value. So what will I do? I'll just try potentiometer value. What is the potentiometer value has been mapped now? It's in M. Hmm, right. Now I will try to run this code. Right. Now if I try to increase the code, you can see it's increasing or decreasing the brightness. Right. This is how you make it. Getting my point now? You understood the entire part? Let me know. Did you understood this or not? Did you understand this part? Guys, did you understand? Let me know. Yes, Anjali, great. Now I hope the homework which I have given you today, I hope you can do it properly, right? So I expect with some creative minds and some creative projects, let me know. Okay, guys. Bye bye. Have a great day, and I hope you come up with a new ideas and projects which you can do with it. Okay, let me know. Have a great day and like night actually. Bye bye. Take care.